Hello, welcome back to my bench. Today we have a Composer Pro XL model MDX2600. This particular one evidently is from 08 of 12. And these things you find all over the place. They're used for studios, they're used for radio, television, they're used just bands. I mean, everybody uses these things because for a couple of good reasons. One is they work, and two is they're relatively inexpensive. They don't cost that much. And we'll just take a look and see what's in it here, or what's on it. Here we got, here's the front panel. And as you can see, it's got two full channels, this one and this one. It has an expander with a gate that's changeable. It has a compressor and a limiter so that you can even out your speech or whatever you're playing through it, so that when you quit talking, it doesn't rise up to that rush that we had in the 70s on TV. We called a wall of sound. But it'll raise the background up some and then cut it back down again, and it's controllable on how fast it does that, and they do a very good job of it. It's got a de-esser for sibilance in voice and that kind of stuff, and it's got a peak limiter so that you can set your peaks so that it won't go over a certain threshold. Off is over here. And it goes, from 0 through 15, 16, 17, 18, whatever that means. dB, I guess. I don't know. But that's its, peak limiter. And it will either run in dual mono mode so that both channels are separated from each other, or you can put it into stereo couple with channel 1 as the master for your stereo, so that you only work on one side of the thing, and it plays with both channels more or less. Let's see what else. That's about all it's got, but that's enough. Now you can't use this as a mic processor like a 528E or 528, because it takes line level input, which is back here. We have you got your inputs here, females are inputs, and you got your outputs over here, and you've also got side chains that you can put things in here to do other processing before it goes through it. It also has operating level of either +4 or -10 depending on what you're feeding it. So back there, and there's the power supply input. And now if we open this thing up, comes the big surprise. There's pretty much nothing in it when you first look at it. It's just kind of empty. I've already taken this loose because we're going to have to fix it. But basically what you got here, you've got your input and output boards back here in the back. It's got a couple of regulators on it. This is a plus or minus 15 volt power supply. And it's got these cables, just plain wires, not ribbons, but plain wire cables that connect to the front here. And this board in the front's got everything else on it for all of the stuff, all the push buttons and everything. Getting that board out of there is kind of fun. It slides slides into little rails down here in the bottom, and it's got to take all the knobs and everything off of it. I don't think that's the problem we got with this one. So we're going to hook this up, and I'll show you, what it's supposed to do, and because one channel in this thing is working. Okay, so we'll hook her up here, give her some power. Okay, we got power. Now, if we take a look at the output, this is on the scope. I'm feeding the scope. It's right. Just feeding it into there. 600 ohm on the output. and it's going into, and it's right now it's in bypass mode. That's the nice thing about these is when they die or quit or you turn them off, the relays actually go click and it just goes into bypass mode. The little relays are down here, one over here. Alright, so everybody is off on here. I'm going to turn it on. As you can see, nothing happened. And then I'm going to turn on the channel itself. Wait a minute. Okay, turn on the channel itself, and now I can control the output level from way down to way up. So we can go to what, 3.9, almost 4 volts, all the way down to 200 millivolts. And at 0, we should be about 2, which we are. And if we look there, this knob is on 0. My reading on the meter is at 0. If I turn my expander, you can see that it's cutting down the level because I'm telling it to cut the level down at a certain point. And I can change the gate so that it's fast or slow. There. And cut it all the way down to nothing if I want to all the way plus 10 off of it, which would be 0. So, and you can see your lights here all the way down. See? So basically, it works a lot like a 528E without the mic processor or the mic preamp. So that's what it's supposed to do. Turn it off. Here, turn it on. You know, crank it up nice and heavy. Turn it off, and we're back to our 2 volts input for 0 level, which is what I'm feeding it out of the Hewlett-Packard oscillator. Alright, that's how it's supposed to work. Now let's take a look at the other side. Over here. It's off. Alright. Whoops. Stay. Alright, so if you look on the scope, you can see that we got our input level is where it's supposed to be, and it's in bypass. And let's turn it on here, and it drops it down, and it gets square waved on me badly. There's my output bypassed, there's my output cranked up, and nasty looking square wave. So we got a problem with the output of this thing. That's back here. So we'll disconnect it, take it apart, and see what we can find. First thing we got to do, always, is to, there we go, we want to check the voltages, and our voltage, put this on volts would help. Alright, ground, there's a ground. And voltages are going to be, there's 22 volts in, plus 15, minus 14.58. So the voltages are fine, which we could have guessed because the other channel works. But this channel's not working right, so we got to figure out what's wrong with it. Unplug it. Okay, and pull this out. I already took the screws off the back. You don't need to watch me do that. There's the little relay I was talking about. Zoom in a little bit. There's your relay. There's the relay for that channel. And the way these things work, let's get rid of that. Alright. Now, if you look over here, here's your input over here. That's this input. It goes through this 4580. Let's open this up a little bit. Goes through this 4580, which on this one, alright, let's stop this one here. Don't need to be recording that. Okay, let's see, get my glasses on. Where is it? It is going to be IC4, and that's going to be right. IC4 is right there. Move over. Yeah, IC4 is right there. You can't really see that because of everything's in the way, but it's right there. And then it goes through this IC over here, which is a 2159B. Well, this one's a B. Over there, which is a voltage controlled amplifier, and a buffer up here, up here, and down to your output. The rest of it comes down through this capacitor and into this 4580, which is IC5. IC5 being right there, and then it travels on through some stuff and goes over to, well, after it comes out of IC5 and IC6, which is, where's IC6? 3, 4, 5. IC6 is up under there. Then it buggers off out to the front board where all the controls are, and then it comes back in pin 6 over here and goes into that IC right there, which is IC7, I believe. Let's see. IC6B. Yeah, IC7, which is right there. Alright, so what we need to do is we need to kind of isolate this a little bit. I'm going to use a rag because it's what I happen to have on hand. We're not dealing with high voltages. It's all over here, and it's not a big deal. Alright, let's pull this out a little bit. Okay, so we'll plug it in. We'll give it an output here, an input here. Turn it on. Yep. Alright. Let's turn this guy back on again. Alright, and turn that off. There we go. Alright, now we'll take the scope, the other line. We'll turn off channel 1, turn on channel 2. That's me. And I'll get something for a ground here. That's chassis ground. I'm not sure that would work. I don't know, maybe. I can find out. Let's see. Anyway, so let's see. Let's go to make sure that we're getting clean where we need to get it, and that would be that IC4, which is over here. So let's pin 7 of IC4. There we go. That's a nice, good, heavy-duty signal. Let's see. Let's take this thing down to what is that? Half a volt. Yeah. So IC4. There we go. We got our 2 volts almost. So that's pin 7, so that's the output of IC4 right here. That's the voltage control. That's not going to help me, so I want pin 1 of IC5. So that's going to be right there. So we've got, that will not change with the level, or yeah, it doesn't change with level. It changes a little bit when I actually turn the unit out of bypass, but that doesn't change. Then we got IC5B, which is 7, which is right there. That doesn't change. It's not supposed to. That's more or less of a, well, 10K. It'd be some amplification, but it's going through a bunch of stuff. Alright, so we're going to pretend like the whole front board is good, because I don't want to have to tear that out if I don't have to. So let's go over here to IC7, which where it comes back from the main board here, up front, and it goes through these resistors and This IC6B. Yeah, I don't know. But anyway, it goes into this right here. So let's go to pin 6 of IC7. So pin 6 of IC7. Bring us in a little bit so you can kind of see what I'm doing. Pin 6 of IC7 is right there. Actually, you have to turn it on now. Pin 6 of IC7 is right there. Pin 5. Okay, so there's pin 5, which is our input, non-inverting input. And then pin 7. Pin 7. Okay, I have nothing on pin 7. How about the other side of that chip? Got pin 2. Pin 2, that's the input. Ah, where'd you go? Come on. There's pin 2. And pin 1, which is the output of that side of that IC, has a little bit of something on it, which I can control just barely. Alright, so, but we do have voltages there, right? Pin 4. Let's see, I didn't switch it over there. Pin 4 is minus 14. Pin 8 is plus 15. Yes. So we got voltages. Well, I'd say it's a pretty good bet. At least to begin with. That chip is bad. Okay, so that's a 4580. I don't have any 4580s. Okay, well, let's see. Let's pull this guy over here. And maybe I can video this. Let's get rid of this for now. We'll go over to here. Yeah. Alright, we'll turn on the... and we'll record that. Alright, so that's a 4580. I think this thing's been worked on before. Look, see? Alright. Let's turn on the hot gun. And I think I'm going to use a 5532. I'll show you the schematic, but I think 5532 will work just fine. Problem is, my 5532s are not the same size. If we look here, come on, turn over, darn it. Alright, that's this 4580. There's my 5532. The pins don't stick out as far, so I think I can make it work. Alright, we're up to temp. Let's take this guy off. Give him a little bit of... okay, I can stop you. Okay. Facilitates the taking off of parts. Alright. Ta-da, that's off. Alright, let's clean it up a little bit. These things have been around for a while. I think this is even a moderner sort of one than the other ones. One of the versions of this, the whole bottom is full of stuff. It's all through hole, This one's not. It all went away. I opened up one of these one day and I thought, where did everything go? Okay. Alright. What did I do with you? Okay. Make sure I get it around the right way. Since this is not exactly the same size chip, I am going to hand solder this in here because I got to get it kind of right at the edge of its little legs. Ugh. Trying to make it so you can see it too. Okay. How does that look? Okay. Track her down. Whoops. Okay. I think I won't know until I clean it. Yuck. That is looks awful under the scope, doesn't it? Alright. Trust me, it doesn't look that bad from here. Okay. Alright, how's that look? Where'd that go? Wonder if I can put some more, like, sideways light on this thing. Oh, that side's definitely soldered. That side is definitely soldered. And it's going the right way. All the rest of the parts are still on the board. Yep. Alright. So, let's stop the microscope. And we'll go back over here. Get you out of the way. Alright, now let's plug this back up. Everybody is in non-shorted mode. Alrighty. Bring up channel 1. Okay, we're on channel 1, and that is input. Turn it on. Nothing. No change. Shouldn't be, because it's not turned on. Now we'll turn on the amp. Whoa! There we go. Now we can control it. Let's take it all the way up. And, well, if I crank it all the way to the very, very top, I'm getting square waves. I'm putting too much into it. So let's back it down a little bit. Okay, we'll back it down to there. Take it, bypass it. And what do we got? We're on what, 0.2? So we got 1 volt peak to peak going in. Well, coming out in bypass mode. Turn it on. And there we go. And it says, well, wait a minute, output. Okay, there's my output level. And it is 2 volts. Perfect. Just what it's supposed to be. Alright, so that was it. The little chip right there. Tell you what happened to it. You got hit by lightning, I can guarantee you. These things, if you look at the schematic over here, there is nothing. If you've got a cable connected to this, going to who knows where in your rack, and then you lead it through here and it's running, well, the only thing stopping it is this 6.04K resistors to blow the heck out of this front end of these things. So right there, you're gonna blow that, and you're gonna blow that, and that's exactly what we did. So that fixed it. Now she works just like she's supposed to. Beautiful. Let's see if the expander gate works. Yep. I turn it down, and if I turn on the, let's see, turn on the compressor, and I turn it up, yep, it's trying to hold it, it's trying to maintain it as best it can. Yeah, you can't crank it too hard. Alright, so that works. Alright, we're going to put this thing back together, and then I'm going to hook it up to the hook it up to the distortion analyzer, and we'll make sure that the output looks good. We'll be back in a minute. Okay, well, we're back, and basically I got it put together just enough to test it. We're going into the channel that we just repaired. And we're going to look at the distortion analyzer over here. It's about the best picture I can get of it. Unfortunately, I don't think I can. Can I, like, maybe set this thing in here somehow? Okay. Oh, this is going to be touchy. All right. Here we go. Like I said, I got it all hooked up here. We got it running into the distortion analyzer. We'll set our level. This is not one of them fancy new ones. Set the level for what we got coming out of it. Then go to distortion. Crank it down a little bit. Oop, about there. Tune in the frequency, which is about there. About the best I can get out of my setup here is 0.3 or 0.4. So let's see, tune the frequency, tune the null. Okay, well, looky there. We got what is that? That's on 1 full scale, so we got 0.3234. 0.34. So that'd be 0.1, 0.2, 0.3, 0.35-ish, 4-ish, something, I don't know. But it's around there, which is exactly what we want. All right, now, that's for the direct input. Now, let's do this. Take it back to level. Input level, and crank our input level so it was where the other one was. About there. A little bump isn't working quite right. There, the knobs are knurled. Anyway, and we're still. Yep, that's 0.1. We're still at 0.3, 0.35, 0.34. So my 5532 did just fine as far as distortion goes. So it's working. I'm happy. Will work. I don't think there's anything else wrong with this. I'm going to let it burn on the bench for a couple of good hours. I got to turn it off now because these things are going to get warm. A couple of good hours and make sure that it's that it works. But all right, there we go. Fixed it. Just little IC over there on the output because it literally got smoked by lightning, or at least discharge, static discharge. Probably static discharge, not lightning, because, well, it's all the same thing. It's just easier to get the discharge than lightning, especially if this was in a station, and I believe it's in a station with a connected right to with the towers right outside the window. If that's the truth, then yeah, these things will they're susceptible to it. That's why you always want to have anything you run in your building in a radio station with the towers around you. You want to have good surge suppressors, a lot of them, because those towers, I'm telling you, I've sat outside and watched as lightning bounced around between my 265-foot towers, and it's quite a show. But it does, you gain a lot of respect for lightning. Anyhow, there we go. Hope you enjoyed it. If you did, give it a thumbs up that way, and don't forget to hit that bell down there if you want to see more that I do. Or boy, I'm trying to think of the word. I can't think of the word right now. It's not register, but you know, you want to be. Anyhow, hit the big subscribe. Hit the big subscribe button. Hit the bell, and then you know when I'm going to do more of these things. Anyway, thanks for watching. Stay safe out there, guys.